So, einen schönen guten Tag, meine Damen und Herren. Ich übernehme jetzt den Part von meiner Kollegin Frau Thurn, die das gut gemeistert hat vorhin. Mein Name ist Karim Abbas, ich bin von der Fachhochschule Aachen und genau, auch ebenfalls im Bereich additive Fertigung unterwegs, unter anderem Spezialist in der Dirolfschen Kraftschlusswinkel. Nun denn, ich möchte gerne das nächste Thema einmal kurz vorstellen. Wir sind hier in vielerlei Segmente unterwegs, unter anderem im Metallbereich der additiven Fertigung, aber auch im Kunststoffbereich. Die wesentlichen oder wichtigsten Materialien sind, wie gesagt, die Kunststoffe als auch die Metalle. Wir sehen hier viele Anlagen auf der Messe, aber was passiert eigentlich in der Materialforschung? Also wie geht es weiter mit den Filamenten, wie geht es weiter mit den Kunststoffpulvern? Wo sind da die Hürden, wo liegt da die Zukunft und was wird in nächster Zeit dort passieren? Dazu wird Herr András Marton uns heute etwas erzählen. I would like to kindly welcome Mr. András Marton. He's going to give us a short introduction to the insights, overview and insights into newest developments round about plastics and other materials. Thank you.
Thank you. So I'm very glad to be here. We have no booth here, so it's great to have the opportunity to hold a presentation. My name is András Marton. I am Marketing and Sales Manager actually for Photopolymers within BASF 3D Printing Solutions. I will give this presentation in English because I know at least one person who is English speaking, so let me continue in English. Yeah, stay curious is our claim. There are many things to come. I hope the presentation won't get too detailed, yeah, and I hope I meet your expectations in terms of what is coming next, but at least you will see what we have in our portfolio throughout the different 3D printing technologies when we speak about materials, services, solutions. So, as a starter, maybe a small intro into our company. You know maybe BASF as a large chemical company. We have a lot of employees worldwide, over 110,000 actually, and our last sales figure was over 60 billion euros. Now, since September last year, we established a new company, a 100% daughter company, located in Heidelberg, called BASF 3D Printing Solutions. And yeah, our team is growing. Yeah, we started little a few years ago, and we are quickly growing. Yeah, so my colleagues are also running around for the other technologies to see what is going on in the market. And of course, at Formnext, then we will have our booth again. Yeah, so maybe a short overview into the different, let's say, products we offer inside BASF. Why am I showing this? Because it might give you an insight into where are we coming from and what does that help us to provide better materials for 3D printing. So you can see we are actually active in almost every value chain step in the chemical production, yeah? From oil and gas to specialty chemicals, also agriculture. And that leads actually to a broad portfolio of raw materials, which we can sell, but of course can use ourselves as well if we develop formulations and materials for 3D printing. Yeah? So metal ceramic powders, acrylate solvents, photoreactive chemicals, plastics, of course, coatings, UV curing experience, and so on. Now, when we come from the chemical value chain to the 3D printing value chain, yeah, we have the raw materials and the 3D printing formulations, and we are, of course, active here, providing raw materials to material suppliers as well, and to printer manufacturers, and final formulations to use. Yeah? But also simulation and design. Yeah? So coming from the injection molding business of our plastics, engineering plastics business unit, we have a lot of experience working together with the different industries, automotive industry to name one, how to simulate part behavior and so on. Yeah? And this we can adapt now to 3D printing materials and printed parts. What we do not offer in the 3D printing value chain is actually equipment. Yeah? So this is the only, let's say, value we don't generate. Yeah? All other value chain steps we are present in. So we print parts, we offer services in terms of testing materials, testing parts, and so on. Now, let's take one step more into detail. What does that mean? What do we offer? So we are spread into the different technologies: powder bed fusion, FFF, photopolymers, and services. And you can see here the portfolio, which is constantly growing, of materials we offer. Yeah? Now let's have a closer look into powder bed fusion powders, plastic powders. We have currently on the market, under our brand name UltraSint, different versions of PA6. Why PA6? Because I will show you in the next slide a little bit the difference compared to PA12, what it means when we come to applications which supply industrial functions, in parts for industrial use cases. Yeah? And PA12, the properties are not enough to fulfill those requirements. With PA6, of course, machines are still not that broadly available and quite expensive in terms of one-time investment. But on looking at material properties at the end, it is very valuable to think, or when you think about small series production, industrial parts, and so on. So we have here a black version, glass beads filled version, mineral filled version, different grades. And working also on others, a PA12-like material, and others. Now this is a small comparison when we compare PA6 to PA12. You can see her qualitatively on the right, and here on the left is actually a test. What happens to a 3D printed bottle? Let me see if that is on. If it's loaded with 34 bars at 90 degrees. So it can withstand that for quite a while with only 2 millimeters, but then bursts, of course, and this would be simply impossible with PA12. Unfortunately, this does not work, so you would have seen how it bursts. But now it's even better, it doesn't burst. So, and of course we are also in the flexible powders, so with different partners together, developing materials for them, and also working on specific chemistry to have other grades of flexible TPU powders as well. Now let's come from powders to photopolymers. Yeah? And what have we seen on the material side out in the market? What is still missing? What do customers tell us? Yeah? So in the area of photopolymers, high impact grades are still missing. Yeah? Part costs are very high. Long-term endurance is a topic. And flexible grades are also needed. And scaled production. And this is one topic where we want to be prepared, and we are prepared for the future when material supply is going to rise, where we can use existing facilities to produce our materials and don't have to invest to build up new production plants and so on. So how do we address photopolymers? We have one existing material on the market. We still call it Resin X004. This is the M version. We are working on the branding, don't worry. But it's a quite nice start, where we told our R&D folks, please get something on the market as quick as possible. And we actually found out, wow, it's already quite even better than most of the materials out there. Yeah? So if you have if you understand the values and you quickly look at these, especially at the impact strength, then you can judge this is significantly better than other materials, which are named maybe even tough resins. Yeah? And what is very special here is that it is a multi-purpose resin. So it fits actually with every printer technology, so SLA, DLP, LCD, wavelengths from 355 to 405. So we are actually ready to sell it to anyone, theoretically. And here you can again see a little bit of feedback what we get from different printer manufacturers, be it DLP, reverse DLP, SLA, reversed SLA, or LCD. And actually everybody sees that the material is working on their printers. So it depends on them how they incorporate the material. Do they take it up into their portfolio? Do they allow customers to buy directly from us? There are different models out there. We always proclaim the open business models, because we want to have, or we want to push available different materials to push 3D printing, but we are open for a lot of business models. Now, another topic in photopolymers is ceramic photopolymers. This is quite new. We are focusing here on investment casting, meaning that we replace 4 process steps in the traditional core shell production of investment casting. By eliminating that, we save some time and costs combined with tool making and so on. And we directly enable the shell printing with our ceramic photopolymer material, which is actually also applicable in many printers. And currently we are working here with selected partners to let's say implement or to use even their ceramic material and implement it in our formulation, or to see what their application and requirements are. So this is nothing which is available to the broad market yet. We are in test marketing, let's say it like that, with selected partners. Now let's go to filaments. Here we acquired a company called Innofil 3D. We bought in quite some materials here and a nice high quality production. So Innofil 3D is supplying, let's call them standard filaments, which we can supply globally. And with the mentioned plastics business unit we have inside BASF, we supply already granulates to different markets, industries. And so we are working on putting these granulates, different types, grades of engineering plastics into filaments. And you can see them here. So filled filaments, high temperature filaments, engineering plastics. And the brand name for these engineering plastics filaments is UltraFuse. So we have UltraSint for powders, we have UltraFuse and Innofil 3D for filaments. And a last area of filaments is then our metal filament, which is quite neat. So you can actually use it in almost any FFF printer and get a first part out of it. I will show you later on what kind of a post process is required to be able to have a purely metal part in the end. But this enables this, let's say, material, and then the process in total enables with significantly lower investment costs to produce metal parts. So here you can see the process. So you have the filament, you shape it, you print it, and then you receive a first green part. The filament contains 88% of metal powder, and the rest is binder, and which you have to then debind. This is the first catalytic debinding process. Then you receive a brown part, and after that you sinter it. And this whole process chain is actually a standard process chain which is known to the metal injection molding industry. And shrinkage, you can calculate and then design the part bigger that you have the final end part you wanted. Now let's go away from the different technologies and materials we supply there and talk a little bit more in general. So what do we want 3D printing to become? Yeah? We want 3D printing not to stay in prototyping. Of course, it will always stay there, and it's good, but not only. Yeah? And we are pushing actively with different materials, yeah? With a higher material choice, availability, and with lower costs to achieve that goal. Yeah? And this is only qualitative here. But I can tell you throughout the different technologies, yeah, we supply material to, this is the picture we see and we actually actively want to see. Yeah? So, yeah, because material price, material cost is the driving factor when you increase volume, and increased volume is then, existing when you have 3D printing in small series production in industrial use cases. And maybe to mention this gap here, yeah, so most of the suppliers struggle with scale up. Yeah. We are maybe not there yet. Yeah. There are quite some applications where there is, let's say, a high volume behind, but the whole industry itself is not there yet, but slowly getting there. And we are prepared for this year, yeah, going up in volume. So, last but not least, yeah, why should you choose us as a partner, as a material supplier? Well, scale up, as mentioned, yeah, should be no issue at constant quality, free material choice, then our strong R&D network, which we can use around the globe, which we are using. We have an in-house application technology center in Heidelberg, where we have different printers from different technologies testing our material on and printing parts. And maybe the most significant value proposition, let's say it like that, but the difference is that we can use our raw materials, which we specifically now also start to design, yeah, to formulate, to synthesize for 3D printing. We can use them ourselves. Yeah? And there we will, let's say, wisely decide which new raw materials we synthesize we will sell as a raw material out to other material suppliers, and which ones we will take ourselves to put into our formulations. Yeah? So thank you very much. I had no time, so I hope I am in time. In case there are any questions, please go ahead.
Thank you, Mr. Marton, for your presentation and for your time. Are there any questions to that topic? No? Okay, I just got one maybe specific question. You showed us some fields of applications, and you talked about photopolymers. Do you think, or is there, how is the future of photopolymers in biomedical use? Or is there...
In general, or within our, let's say...
Within our
organization?
Yes.
So we are looking at that, but you probably might know that to be able to supply into biomedical application, it's always the whole, let's say, process which has to be certified. Yeah? So you need a printer, you need a post-process established, you need exact procedures. So it's not only the material, but we are starting, or we have started to develop materials for biomedical applications, but this involves a lot of partners, work with partners. So this will come, we won't go into the very last detail, For example, we won't let's say, develop materials for implants which are with blood contact, something like that. But for example, dental aligners, prosthetists, this is everything, of course, we look at.
Okay, thank you.